Okay. For the derivatives of inverse trig functions, hyperbolic functions, or hyperbolic trig functions, and the chain rule. So let's get started. Inverse trigonometric functions. What are the inverse trigonometric functions? These are exactly what their name says. If we have a functions such as f of x equals 2x, the doubling function, then the inverse function would be that which undoes it. So it would be the halving function. So if f of x is 2x, then the inverse of f, would be x over 2. And for the trigonometric functions, they will have inverses, but their domain has to be restricted because the trig functions are many to one. For example, sine of 0 is 0, but sine of pi is also 0, and sine of 2 pi is also 0, and sine of 3 pi is also 0, and so on and so on and so on. And therefore, if you want to invert the sine function, you have to restrict the domain. Otherwise, you won't get just one output back. So the domain of the inverse sine function is -1 to 1, and the range is minus pi over 2 to pi over 2. And what about the inverse cosine function? Well, the domain will be -1 to 1, and the range would be 0 to pi, I believe. Okay, and as for the tangent function, well, the domain would be the entire set of real numbers, and then the range would be minus pi over 2 to pi over 2, exclusive, because, of course, tan of pi over 2 is undefined, and tan of minus pi over 2 is undefined. Anyway, what about their derivatives? D by dx of arc sine x is 1 over root 1 minus x squared, and d by dx of arc cosine x is -1 over root 1 minus x squared, and d by dx of arc tan x rather. And by the way, when I say arc, that's my way of inverting the trig function. So inverse sine is also known as arc sine. Inverse cosine is also known as arc cosine. Inverse tangent is also known as arc tan. And likewise for arc secant or arc sec, and arc cosecant or arc cosec, and arc cotangent or arc cot. So as I was saying, d by dx of arc sine x is 1 over root 1 minus x squared, and d by dx of arc cosine x is -1 over root 1 minus x squared. As for the inverse tan and inverse cotangent, d by dx of arc tan x is 1 over 1 plus x squared, and d by dx of arc cot x is -1 over 1 plus x squared. And lastly, what about arc sec and arc cosec? Well, d by dx of arc sec x is 1 over the absolute value of x multiplied by the square root of x squared minus 1, and d by dx of arc cosec x is minus 1 over the absolute value of x times the square root of x squared minus 1. Anyway, with that knowledge out of the way, let's begin with the practice problems. There's only five here, and hopefully there will be more when we get into the chain function, or the chain rule rather. So if t of z is 2 cosine of z plus 6 arc cosine of z, what's the derivative? So t prime of z would be minus 2 sine z. And then here, this would just be 6 times the derivative of arc cosine of z. So it would be minus 6. Just like that. We'll do the second problem while we're at it. So if g of t is arc cosecant of t minus 4 arc cotangent of t, then what is g prime of t? G prime of t would be that. Let's see, cot. So it would be a plus 4 here over that there. So we just check. That's correct. That's correct. Third problem. So we'll compute dy by dx. That'd be 30 x to the 5. And arc sec x, that would be, because it's being subtracted, like that. So we have f of w equals sine of w plus w squared arc tan of w, and that's the product right there, so we need to apply the product rule. So f prime of w would be cosine of w plus 2w arc tan w, and then the derivative of arc tan is this. It would be there just like that. And for the fifth one, we have a quotient to contend with, so we apply the quotient rule, and that goes f prime g minus fg prime over g squared. So f prime g, so we must find the derivative of arc sine x. The derivative of arc sine x is rather d by dx of arc sine x is 1 over root 1 minus x squared. So just like that. f prime g minus f g prime all over that. So that's this. Just like that. And then thinking about this a little bit more, we can actually simplify this into this. Or should I say pseudo simplify? Because that's what I think is the answer. Wait, did I check that one? Not sure if I did. Here we go. There. Okay, that's correct. And I guess they didn't feel the need to simplify that. Right, okay. Right, okay. They presented it in a different way, and that's absolutely fine. So, because there were so few, I do feel the need to do just a few others here from the assignment section, although I do recognize that I won't be able to check these. F prime x, I would say, is cosine x, and then just do 3. C prime of t. Arctan of z. Arctan of z. Perhaps I'll do 5. I don't want to overindulge it, but I also don't want to underdo it. H prime of t. And then here's a product to do three t squared and then this is a product. Like that. So that's derivatives of inverse trig functions complete. Next up, derivatives of hyperbolic functions. Derivatives of hyperbolic functions. So it's important to know the standard results. Actually, it's more important to know the definitions. So, why does it always slip my mind? One is half their sum and the other is half their difference. Okay, just try and think through it logically, or try and think through it using whatever means you can. So, I know that these are analogs of the circular trigonometric functions. I know that the I know that cosine x is an even function, and so cos x will be an even function. And so I believe that cos x is half the sum. So cos x is e to the x plus e to the minus x all over 2. Sin x is e to the x minus e to the minus x all over 2. And then tan x is sin x over cos x. And resuming, continuing, until we get into the real. Okay. And it's back, and well, begin again with the chain rule. So Yes, I want to do every single one of these and to read the functions aloud. And the reason why I'm reading the functions aloud is because it gets my ears used to the sound of mathematics. I'm already well used to the sight of mathematics, but I want to get used to the sound of it. So f of x is 6x squared at 7x all to the power of for f prime of x. Finding f prime of x, we differentiate the outside function, leaving the inside one alone. And then multiply that by the derivative of the inside function, which is 12x plus 7. And so if need be, I can multiply 4 by 12x at 7, which is 48x and 28. And if need be, those could be multiplied out. G of t is 4t squared minus 3t plus 2 all to the negative 2. So g prime of t, differentiating the outside function, we get minus 2 times 4t squared minus 3t plus 2 all to the minus 3 times 8t minus 3. And if need be, I can do this. Like that. Y equals the cube root of 1 minus 8z, and therefore y is 1 minus 8z all to the 1/3. So dy by dz would be 1/3 of 1 minus 8z all to the minus 2/3, and then multiply that by negative 8. And what does that mean exactly? That there means the cube root of 1 minus 8z all squared. And so we have this. That should be sufficient for that. And now we must check. Everything must be checked. Great. So it's in one of those moods where it's going to take ages to load. So I'm just going to move on. R of W is cosecant of 7W. So what's the derivative of cosec x? Trying to remember. Just reload the entire page. It's just see, Google works, but Paul's site does not work, and it's perplexing. I really don't know why it doesn't work, but for some reason it doesn't. Anyway, minus cosec x quad x, that's what it is, isn't it? So r prime of w would be that would come on the outside, so minus 7. Like that, I believe. Now, just to check, works just fine, but here does not load. I always have to restart the internet every single time. Super frustrating, but here we go. Okay, so back. Yes, it is. Got to check all these results. First one. Okay, but I decided to multiply the 4 throughout. That's correct. Second. Okay, I decided to do something a little bit different, but that's totally fine. Third. Yep, that's the same. Fourth. That's correct. Problem 5. G of x is 2 sine of 3x plus tan x. That surely is a case of the chain rule, isn't it? So g prime of x, differentiating the outside function, leaving the inside one alone. And then differentiating the inside one. There. H of u is tan of 4 plus tan u. So h prime of u, d by dx of tan x is x squared x. So, beg your pardon here. Like that. F of t is 5 plus e to the 40 plus t to the 7. So this 5 here doesn't really matter, that just disappears. But I want to show that I'm aware of this alternative notation. So it's t to the 7 plus 40, just like that. And so f prime of t, that would disappear, differentiating the outside one. The derivative of e to the x is e to the x, so we leave the inside alone. And then multiply it by the derivative of the inside one. We get that. But I suppose they would want it in their own notation, right? So 70 to the 6 plus 4, all times e to the t to the 7 plus 4t. there like that. And we shall check this. Everything must be checked, because without checking, there is no computing. Okay, that's correct. And that's correct. And what about this? That's also correct, and that's good. Right. Let's now think. G of x is e to the 1 minus cosec. G of x is e to the 1 minus cos x. So g prime of x. Differentiating the outside one, leaving the inside one alone, and then multiplying that by the derivative of the inside one. So what is the derivative of minus cosine of x? Well, sine goes to cos, and cos goes to minus sine. But because there's a minus in front of it, it would go to sine. So sine x, just like that. Next, h of z is 2 to the 1 minus 6z. Here we are differentiating a to the x. The derivative of e to the x is e to the x, as you know. And what about d by dx of a to the x? That's ln a times a to the x. So to differentiate the outside function, h prime of z would be ln of 2 multiplied by 2 to the 1 minus 6z. But then we have to differentiate the inside function. So that would actually be minus 6. Minus 6, just like that, I believe. I haven't checked yet, so I don't know. Okay, next up, arctan. So d by dx of arctan x is 1 over 1 plus x squared. D by dx of arctan of x is 1 over 1 plus x squared. So in this case, we're working with t. So I believe u prime of t is, wait, hold on. Don't I do this? Right? And then times that by the derivative of that, which is 3. Just simply 3. So 3 would go on top. And perhaps they might want it as 9t squared minus 6t plus 2. Perhaps. Don't know. But now we must check. Everything must be checked. Okay, that's correct. That's correct. That's correct. Next, doing the next problem. F of y is the natural logarithm of 1 minus 5y squared plus y cubed. So what is f prime of y? What's the derivative of the natural logarithm? 1 over x, right? d by dx of ln x is 1 over x. So then differentiating the inside one, that will be on top, won't it? Okay, so it's going to be 3y squared minus 10y. That guy disappears. All over y cubed minus 5y squared plus 1. I believe, but I don't yet know. V of x is the natural logarithm of sine x minus cot x. So let's do it. V prime of x. Well, let's see. So that's going to be our denominator. And as for our numerator, d by dx of sine x is cos x. D by dx of cot x is minus cos x squared x, I think. Yes, I think that's right. So it'll be plus. And we do 13 and then we check. Going to do them in threes. H of z is sine of z to the 6 plus sine of z all to the power of 6. I get it. Okay, so I actually don't know how to read this aloud in a way that the difference between them can be heard. So I need to think about that. But right now, I'm just differentiating. Okay, so the outside and leave the inside alone then. So what will I get? 6z to the 5. Cosine z to the 6. Then what's happening here? What's happening here is sine of z, the function sine of z is being raised to the power of 6. So to properly differentiate that would mean 6 goes here, 5 goes here, and let me think about that. Wait. Yes, that's right. That is right, isn't it? Yes, that's right. Okay, 6 cosine of z sine to the 5z, like that. And we check. Everything must be checked. Okay. The terms are in a different order, but that's correct. 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 Okay. Okay, continue. 14. S of w is the square root of 7w plus e to the negative w. So S prime of w, let's see, we're the square root of 7w, so how do you handle that? Well, that's 7w all to the 1/2. So it's a half of 7w to the negative half, and then we have to times that by 7. Isn't that right? So I think that will be like this. I think that's right. And then here, e to the negative w, well, that would just be negative e to the negative w. No? Right. G of z is 3z to the 7 minus sine of z squared at 6. So differentiate. 21z to the 6. Okay, so minus what? I guess that would be 2z in brackets. Although the brackets actually aren't necessary if you think about it. Like that. And, oh, we have to do one more. Okay, f of x is ln of sine of x minus all of x to the 4 minus 3 to 3x all to the 10. Okay, begin. So cos x over sine x, isn't that so? And cos x over sine x is cot x. So f prime of x is cot x minus, differentiate the inside one while you're here, 4x cubed minus 3, x to the 4 minus 3x to the 9, but you forgot the 10. Just there like that. And that should be good, but we must check. Okay, so they prefer to write it that way, which is totally fine. And that's correct. And that is correct. And that's good. Continue. 17. H of t is t to the 6 all times the square root of 5t squared minus t. So this is a product. This is a product. So apply the product rule. So 6t to the 5 times the square root of 5t squared minus t. Then plus, leave the first one alone and do the derivative of the second one. So I'm going to do that down here so that I don't mess it up. Let's see. All of that is to the half, isn't it? And therefore, half comes down the front. This turns into a minus half, and then I have to times it all by 10t minus 1. And that's it. Doesn't look too pleasant, but you know, it's okay. So 10t minus 1 on the top, 2 and a square root down there on the bottom, and 5t squared minus t just there like that. 18. Q of t equals t squared times ln of t to the 5. So q prime of t. This is another product. So 2t ln of t to the 5 plus, and we differentiate ln of t to the 5 down here, though we're getting more used to it now. We know that it'll be that on the bottom and that on the... No, wait. That's wrong. That on the top, right? No, wait. That can't be. No, it is. It actually is. Like that. Man. It just feels strange that whatever. It's just my... Wait, did I do this? Look at that. I didn't multiply by t squared. So it should be 5t squared over t, which is 5t. And there you go. 19. G of w is cosine of 3w multiplied by sec of 1 minus w. It's another product. So g prime of w must be, differentiate the first one, leave the second one alone. So we have minus sine minus 3 sine of 3w. Plus, and now I'm going to have to do this one down here. Okay, what does sec go to again? Sec x tan x. I know that. Okay, so that times the first one left alone. Right? Yes, but I'm going to have to put that there because it won't fit. So now we check. Excuse me, wait, what? 17, no? All right. Okay, that's correct. And that is totally rubbish. Not right. Not right. But how come? What did I do wrong? I forgot that I was dealing with a product. That's what I did. That's where I messed up. Look at that. Okay, so we got the half. We got the 10t minus 1. We got this. But you forgot to multiply by t to the 6. Put it in. And recall product. Okay. Next one is good. That's correct. Next one is seems okay, seems okay, seems not okay because of the sign. Because, but where's the minus 1 coming from? No, I don't actually know where it's coming from. Try and think. Where does it come from? Oh, there, right there. Yes. Okay. Yeah. Okay. $20. Wait, how many are there? Many. Continue. Here we have a quotient. Y equals sine of 3t all over 1 add t squared. So dy by dt for differentiation. And what's the quotient rule? F prime g minus fg prime all over g squared. So you have to be careful. Differentiate that. 3 cosine of 3t. Leave that one alone. Minus g minus fg prime. Leave the top alone. Differentiate that 2t. All over 1 plus t squared squared. And think. Can't think of much to do with this one. Sorry. I think that's really it. But I'm about to be proven wrong without a doubt. Oh no, I got it right. Oh yay. Brilliant. Okay. 21. K of x is 1 plus e to the minus 2x all over x plus tan of 12x. Okay, another quotient. Another instance of the quotient rule. So, k prime of x equals differentiate the top. I swear it's just minus 2 e to the minus 2x. But when so many things are happening at once, I sort of derail a little bit. Differentiate the outside one, leave the inside one alone, times it by the minus 2. So, okay. So now I believe it. Minus 2 e to the minus 2x times the bottom minus sign f prime g minus f g prime. Okay, what's the derivative of that? Okay, think carefully, and I come up with 1 plus (12) sec squared (12x). That's what I come up with. And so top one left alone. bottom one differentiated. And bottom function squared. Better check. Okay, good. So I don't have to simplify that because that would have been a nightmare. That's correct. Brilliant. Okay, I'm happy about that. 22. F of x equals cosine of x squared e to the x. So we have a function of a product. Cos x goes to minus sin x. And then differentiate the inside one, and that is a product. So I make a big bracket here. And now I'm on the product layer. So 2x e to the x plus x squared e to the x. And that's good enough for me. All right, I'm going to check this. That is correct, and that's good. Wait, was it? Something feels wrong. No, it is. It's actually correct. Okay, that's good. 23. Z equals the square root of 5x at tan of 4x. So dz by dx. Differentiating the outside function, leaving the inside one alone. Multiplied by the derivative of the inside one. So that's 5. And what, okay, d by dx of tan x is sec squared x, and that's 4. Like that. There's a more aesthetic way to arrange it, a way that pleases my eyes more. But I understand that he doesn't share that. And that's correct. Brilliant. 24. F of t is e to the minus 6t plus sine of 2 minus t. All of that is cubed. So f prime of t, differentiating the outside function. You're not going to catch me this time. I see the minus sign right there. Like that. That's differentiating the outside function. And now we must differentiate the inside function and multiply. All right, so that is minus 6e to the minus 6t. And that is minus cosine 2 minus t. And we'll check that. Okay, right, okay, that's correct. 25. G of x is ln of x squared at 1 minus arctan of 6x. All of that is raised to the power of 10. So g prime of x. Differentiate the outside one, leave the inside one alone. So 10, open brackets, ln of x squared at 1 minus arctan of 6x to the 9, just like that. And now differentiate the inside one. So what's the derivative of ln of x squared at 1? So I'm going to do a multiplication symbol there just to remind myself to return to that point. So what is it? It's going to be 1 over x squared at 1, and then that's going to be 2x over x squared at 1. All right, okay. Just there like that. And now, what's the derivative of arctan of whatever? Arc d by dx of arctan x is 1 over x squared at 1. Okay, fine. How does that help me? So this will be 6 over the square of 6x at 1 with a minus sign in front. Like that. That's what I think. So I'm going to bring that up there. I'm going to multiply by the entirety of that. And then I'm going to check. Okay, the first product is correct. And that's correct, and that's good. Okay. 26. H of z is tan to the 4 of z. Okay, so the outside function is raising this to the 4. Wait, this is a chain of a chain. A chain of a chain. Okay, so I didn't think he would do this, but all right. So this is f of g of h of x. Like that. And he's asking for the derivative of this. And so that would be f prime of g of h of x times g prime of h of x times h prime of x, going from the outside in, like an onion. Okay. All right, let's see if I can do this. So what are the functions? F is this. G is this, tan of x. And H is this, isn't it? Okay, here we go. For that multiplied by, what's the derivative of tan? d by dx of tan x is sec squared x. All right. Okay. What's the derivative of z squared add 1? That would be 2z. So what would that look like? Need to make it look a little bit better than that, because that looks garbage. Sorry, it just does. Okay, so 8z tan cubed z squared add 1 sec squared z squared add 1. Okay, but then I just think for a little bit. So that's sine cubed over cos cubed, and that's cos squared on there. So, okay, I think that's really all there is to it. Let's see. And that's correct. $27. F of x is the cube root of 12x plus sine squared of 3x, all of that to the negative 1. Okay. If f, wait, what? Oh. If f of x is x to the minus 1, f prime of x is minus x to the minus 2. So, what does that mean? That means that in the middle is going to go on the bottom and be raised to the power of 2, and a minus sign will be in the front. And then you have to differentiate the inside. Okay, so here's my final answer. Will look like this. It will have a minus sign in front. It will be a massive fraction. This part on the bottom will be raised to the power of 2. And then I'll have the inside piece right there. And now I have to differentiate this big inside piece. So this part here, I don't know. Not yet. But here I try. Come on. What happens when I differentiate this? Okay, that is 12x all to the 1/3. So a third of the inside one. All to the minus 2/3, right? And then you have to, wait, what the hell am I doing? What? That's completely wrong. A third of that to the minus 2/3. That's better. And then you have to differentiate that. So that would be 12. And so that would be here. And so 12 over 3 turns into 4. Like that. Then this here has to be differentiated. So, okay. Sine squared. So that's another chain rule. So leave the inside one alone. And now differentiate the inside. Okay, so derivative of sine is cosine. So, and that would be 3 cosine of 3x. So that would turn into a 6. That 2 would turn into a 6. So what? So I believe, oh man, that looks so bad. Whatever. I mean, I hope this is right. I believe it's this. And now we must check. Now we must check. Okay, so we got the bottom piece correct. That's correct. And on the top, that piece there is correct. And if only I had remembered to take 1 off the power. But otherwise, it was okay. There. '28. Find the tangent line to f of x equals 4 times the square root of 2x, all minus 6 times e to the 2 minus x. At that point right there. Okay, then I will. So what I'm going to first do is find f of 2. So that would be 4 times 2 times 2 minus 6 times e to the 2 minus 2. And what is that? That's square root of 4, which is 2, so that turns into 8. 8 minus 6, and then what's that? E to the 2 minus 2, well, that's e to the 0, which is 1. So 8 minus 6, which is 2. So I know 2, 2 is on the tangent line. And now I must differentiate it, and I must find f of prime of x. That there is a it's a product. So no, it's not. No, yes, it is. Oh, right. Okay. Just think for a second. Just think. Okay, that's 4 root 2 times root x, if you think about it. Because I feel like I'm going to start making mistakes if I push too quickly. So I'm going to go down here and take it slowly. So it's that, right? Which is x to the half. That's just a number right there. and a half, well, that comes down in front. So it's like that. So then that will be on the well, I don't need to do anything right now. I can just leave it like that because I know that I'm just going to compute with it. And now this thing here, I know that they have minus signs in there deliberately to catch me out. So I'm going to be aware of that. When you differentiate e to the minus x, what happens? That turns into e to the minus x, right? So it's just going to be plus 6 e to the minus 2x, is it not? I think so. But I'm waiting. Yes. We'll go with that. And that there turns into 2 root 2. 2 root 2 over root x. Two root 2 over root x. And there, plus 6e to the 2 minus x. Or so I think. I'll just leave that there. Okay. Now what? Now we find f prime of 2. So that would be 2 root 2 over root 2 plus 6e to the 2 minus 2, which is, they cancel, then we just get a 2. That's a 1, so that becomes a 6, so that becomes an 8. And so I know, so what do I know? M equals 8 for the line. Now, y minus y1 equals m minus m of x minus x1. Oh no, now I've run out of room. Y minus 2 equals 8 for x minus 2. So y minus 16 plus 2 minus 14. Right, now to check. Okay, great. That's correct. $29. Determine where v of z equals z to the 4 all times 2 of z minus 8 all cubed is increasing and decreasing. We must differentiate it. V prime of z. This is a product. So 4z cubed times that plus z to the 4. Then, whoops. Uh-oh. I forgot what I was saying. Oh, yeah. Differentiate this now. So 3. 2z minus 8 to the 2. And then out comes a 2, and that's it. And so that has to be cleaned up, doesn't it? All right, so the very first thing I'm going to do is I'm going to turn that into a 6. And the very second thing I'm going to do is I'm going to factor. What am I going to factor? I'm going to factor 2. I'm going to factor z cubed. And I'm going to factor 2z minus 8 squared. And then I'm going to open a pair of brackets here. And I'm going to put in 2z for this. No, that's wrong. Just put in 2. And then put in a 2z minus 8. Okay. And then a plus. And then a 3. 3z. And that's good. And continue, continue, continue. Square it. Multiply it out. So we have 4z, add 3z, so 7z minus 16. Now we have a derivative which is all nice and factorized for us. What kind of a derivative would this be exactly? This would be a sextic. It would be to the power of 6. It would be a degree 6, wouldn't it? But it's nice and factorized for us. So, wait, what else do I know? Well, I know that it's going to be shaped like this. So, what else do I know? I know it's going to have a repeating root of a multiplicity of 3, and it's going to be 0. It's going to have a repeating root of a multiplicity of 2, and it will be 4. And then this one here is 16 over 7. So 0, 4, and 16 over 7. And these are my roots. And then multiplicity is important because I'm going to be thinking about how I'm going to graph this. And why am I going to graph it? Because I want to know where it's positive and negative. That's what I want to know. So 0 there, and 4 where? 16 over 7 there, and 4 right there. And then how will it look? How will it look? It's going to look like this. But how can that possibly? No, it won't. It actually won't. That's wrong. Because look, that has an even multiplicity. And so that's where it just touches, just like that. And then it passes through like that. And so there, we now know where it's going to be increasing and decreasing. We've actually found it. So V of Z is increasing for a Z that is less than 0 and a Z that is greater than 4. And decreasing for a Z that is between here and here and between here and here. So I believe. But now we must check. Okay, so that was differentiated. Okay. Okay, so wait, before I look, because I feel like this is going to be wrong. Okay, so no, actually, that's actually okay. So we've got these three. That's fine. Okay. Okay, so I got the increasing bit. Okay. And that bit's okay-ish. But I didn't know about this. Darn it. Okay, so try to understand. Why did this happen? Okay. I'm pretty sure it looks like this, isn't it? Oh no. Oh no. Because of the order in which I put them, I got it the other way around. Okay, so it's this one that has a multiplicity of 2 and this one that has a multiplicity of 1. So it will actually look like this. Let me think about this. Like that. Right? That's right, isn't it? Yeah. So just simply correction. Increasing 4. This. And wait, who is it? Oh yeah, this one. And decreasing just for this bit. That's right, isn't it? Okay, now it's correct. And that's good. 30. The position of an object is given by s of t equals sine of 3t minus 2t plus 4. Determine where in the interval 0 to 3 the object is moving to the right and moving to the left. So we must differentiate it. d by dx of sine x is cos x, so this becomes 3 cosine of 3t minus 2. Now solve this. Okay, so cosine of 3t is equal to 2/3. And then we have let y equal 3t, then this is not really necessary as a substitution, but you know. Our cosine of 2/3 is 0.8411. What else, though? So we have to do 2 pi minus that. And then we get the other one. And then you have to add on 2 pi a few times. Just a few times to each of them. Just to cover your back. 11.7253. 18.0085. And for this one up here, $7.1243. And again, 13.4074. I know this is overkill, but I'm not bothered right now. So if y is equal to 3t, then t is equal to y over 3. So t would just be all of these divided by 3. So I really wish I hadn't done this, actually, but whatever. Wait. Quickly, 0.2804. Next one, 7.1243 divided by 3. This is really inefficient. You should be doing it the other way. Yeah, but I'm too late now, and it's actually just quicker just to actually get through it, right? I know that's going to be out of range, so I don't even know why I'm doing it, and of course I don't do it. So it's not necessary. So next one, 5.4421. That's good enough. 1.8. 11.7253 divided by 3. The only ones we need are these. And then we need to find out where the function is increasing or decreasing. Or rather, that's not true. We need to find out where it's moving to the right or to the left. So I know that the object is not moving at these times. And there's 3. And I just need to find it out for one of them. So what I'm going to do is I'm going to use t equals 1. I'm going to use t equals 1, and I'm going to plug it in. 3 times cosine of 3 minus 2. And that's a negative number. That's a negative number, and therefore it's moving to the left. And therefore it's moving to the left like that, and moving to the right there, and moving to the right there. That's what I think. But now we're going to see if it's correct. Just moving to the right. There. There. And it's moving to the left there. And there. And that's fantastic. Brilliant. I got it. Brilliant. (31) Determine where a of t equals t squared times e to the 5 minus t is increasing or decreasing. So we must find a prime of t. Prior to that, maybe I'll sip some aqua. Man, that's good. Okay, so a prime of t. This is a product, so differentiate the first one and leave the second one alone. So we have 2t times e to the 5 minus t plus differentiate the second one and leave the first one alone. We differentiate this and we get minus e to the 5 minus t. So this is going to turn into a minus sign. And then we have this. Just like that. Now, we have to find out where it's increasing and decreasing, so it helps us if we know where the zeros of this function are. So we're going to factor out e to the 5 minus t, e to the 5 minus t, and then we'll get 2 minus t, just like that. So solve this. So when is this 0? Well, it's 0 when t is 2. When t is 0. And when is e to the 5 minus t equal to 0? Never. I actually do think that's true. So, wait. How does that help you? Oh, it actually doesn't help me at all. Okay. I don't know how to solve this. How does one solve this? We have to, maybe we don't have to differentiate. Maybe we can just overcome it and overpower it by sheer thinking. Well, no. Just determine its behavior around between the zeros. Okay, so just put in 1. That would be e to the 4 times 1, which is positive. And now if you were to put in 3, that would be positive, that would be positive, and that would be negative. And if you were to put in -3, that would be positive, that would be negative, and that would be, doesn't matter, a small number, but that's okay. So I get it. So there you go. So this is what I believe. I don't yet know. Increasing for and decreasing for that's what I think, but we're about to see if that's true. Turns out that's correct. That's great. That's absolutely great. Problem 32. Problem 32. Determine where in the interval -1 to 20 inclusive the function f of x equals ln of x to the 4 plus 20 x cubed plus 100 is increasing and decreasing. Find f prime of x. dx of ln x is 1 over x, so there you go, and then here like that. And then you have to find out where that's 0. No, wait. Now, this is a rational function, and so when a rational function is equal to 0, we only care about when the numerator is 0. The denominator doesn't matter for that. So 4x cubed plus 60x squared equals 0. So this or 0, and that has a multiplicity of 2 right there for this cubic. So what does that mean? There's 0, and there's -15. So that means it will look like that. And so where is it increasing or decreasing? Wait a minute. It's within this interval, isn't it? Right? So this guy here doesn't even matter. Apparently. So I think it's increasing when x is greater than 0. No. I think it's increasing for this and decreasing for this. But we'll see if that's right. And it's at the very end here, so I can only hope. Hope he doesn't build in a trick of some kind. Oh my goodness me. Am I a dummy? I'm just being a total dummy here. Can't believe it. Right, not thinking. Of course. I knew that, but it's just not thinking right. Not thinking enough. So it's actually this. Yes, I know. When the derivative is greater than 0, that's when it's increasing. I know that. Oh, right then. That was long. But it was good. So who's next? Implicit differentiation and related rates. Okay. So wordy word problems. Higher order derivatives. Okay, that'll be good. And logarithmic differentiation. And then chapter 4. But that's for another day. Be well.